You can use u-Substitution with definite integrals as well. And you essentially follow the same process, but you have an extra step involved because you're switching your variables. So I've outlined the steps here at the top, but we'll go ahead and do some examples. For letter A here, we're integrating this function. I'm going to go ahead and begin as usual. I'm going to choose my u and calculate my du. I'm going to move my constant. And now I'm going to check my matching to make sure that the u-Substitution was correct. Just noticed I forgot my x dx. So x dx, x dx. All right, so you can see it looks like everything matches up just fine. So when I write my u integral, I'm going to write my u integral. So the yellow portion is my u, the x dx is the half du. So that's my integral. Now, there's one important thing to know. The upper and lower limits here on the integral. Remember, this really means you're going to let x equal 0 and you're going to let x equal 1 when you apply your fundamental theorem of calculus. Now, if I change my integral to a u integral, I need to change these upper and lower limits to be values for u, not for x. And the way you do that is quite simple. You go back to your u equation, which relates u to x, and you take the x values of your limits, 0 and 1, and you substitute them in for x. So I'm going to put 0 here. I'm going to have 0 squared plus 1, which obviously gives me 1. Then I'm going to calculate u of my x value of 1. 1 squared plus 1 is going to be 2. So when you write your limits of integration, you have to use 1 and 2 because those are the appropriate values for u. And if your integral is in terms of u, it has to be completely in terms of u, including those limits. Now you would go ahead and proceed as normal. Okay, so here's the remaining work. Your answer should be 15 over 8. And again, you can use a calculator to help you through the fractions and the exponents. I like doing it by hand, but either way is fine. Right, so let's just take a look at another example just to reinforce that idea of changing the limits. So I'm going to begin, first of all, I recognize that this is a radical and that ultimately we don't integrate the radical symbol. So I'm going to rewrite it as a fractional exponent of 1/2. I'm going to let my u be 2x minus 1, which makes my du 2 dx. Move my constant over. So here's your u and du setup. I'm going to check my matching. Okay, so it looks like everything is going to match. My last thing to do, though, is again to go back to my original u and substitute in the x values. 2 times 1 minus 1 is 1. U of 5 is 2 times 5 minus 1, which is 9. So when I write my u integral, it's going to be u to the 1/2 power. Integral sign, the dx is the 1/2 du, and my limits of integration will now be from 1 to 9. I'll show you the rest of the work to finish this one off. Remember, when you integrate u to the 1/2 power, you're adding 1 to the exponent. 1 1/2 is 3/2. So you're going to have a 2/3 come down in front. U to the 3/2 from 1 to 9. You're going to substitute. And at that point, again, honestly, you can use your calculator just to plug all that in. I will do it by hand because I just like doing this stuff by hand. And your final answer for this one is going to be 52/6, which reduces to 26/3, or you can give me the decimal equivalent. All right, that's it.